Hello everyone, today we will calculate one more example of conversion between coordinate systems. In last example we have already calculated the conversion between Cartesian to spherical and Cartesian to cylindrical coordinate systems. Okay, now in this example they have given us that to transform the following vectors to spherical coordinates at the given points. That means we have to convert these 3 points, first A, P, second Q and third R, into spherical coordinates. That means spherical, that means what? In spherical we are having 3 coordinates that are R, theta and phi. Okay, so we have to convert these 3 points into x, y and z into r, theta and phi, r, phi and z into r, theta and phi, and same for the case 3. Okay, but in this example what is the new thing that we are supposed to learn? That is, they have mentioned one point. Okay, for A, that means for first case they have given 10 ax at point P, 10 ay at point Q and 10 az at point R. That means we have to convert these points P at given point, to convert Q at given point and to convert R at given point. That means indirectly we are supposed to perform product between these two vectors. Which vectors? First of all, this P point will indirectly give us one vector, Q will give us one vector and R will give us one vector. And already they have asked one vector, 10ax. 10ax, that means 10 is the magnitude and ax is the unit direction. So indirectly this term is one vector and we are supposed to convert this point P into spherical. So we have to perform vector product between these 2 points. So how we will convert or calculate this? So for that we will use this table. Okay, in this table just concentrate, we are having values of column of ax, ay and az. That means we are having value of Cartesian directions. Ax, unit vectors from Cartesian, ax, ay and az, unit direction of x, unit direction of y, unit direction of z, and one row of spherical unit vectors that are unit vector of r, unit vector of theta and unit vector of phi. So how we will use this table? First of all, they have asked us to find 10ax at P of x, y and z. So we have to convert these 3 into spherical with having 10 ax point. So we will consider only first, that is ax, our x. We will not use this remaining 2. Okay, so ax, in terms of ax we have to find ar, in terms of ax we have to find out a theta, and in terms of ax we have to find a phi. So this will form one equation. What kind of equation? First of all, if we convert these 3 points, first suppose x, y and z, into one vector, then this vector can be represented as vector A is equal to magnitude of r into unit direction of r plus magnitude of a theta into a theta, magnitude of phi, a phi, into unit direction of phi. That means we are having different values of ar, a theta and a phi, which will form us one vector A. And how we will find this value of ar, a theta and a phi? For that we have to use this table. Okay, from this table we can write that for x point, for point in x direction, we will use this ax only. How we will calculate that? First of all, ar, that means this AR will become AR is equal to AX into sin theta cos phi. Second, A theta is equal to AX into cos theta cos phi. Third, A phi is equal to AX into minus of sin phi. Okay, you can see here AR is equal to minus AX into sin theta cos phi. A theta is equal to AX into cos theta cos phi. A phi is equal to AX into minus of sin phi. Okay, we have simply just used these values from the table. Okay, we have already used two tables to convert Cartesian to spherical and Cartesian to cylindrical. Now in this example we will use one more table. Okay, this table is derived from the theory, so we are not going to discuss them all here, but we will use these values from the table right now. Okay, so for X, that means for first A, we have plotted all these values. Second, for Y, that means for AY, how we will find out for AY. Same thing whatever we have done for AX or AR, now we will find out for AY. That means AR is equal to AY into sin theta sin phi. A theta is equal to AY into cos theta sin phi. Same way, A phi is equal to AY into cos phi. Okay, to find out values of AR, A theta and A phi, we will repeatedly use value of AX in this table, AX into cos theta cos phi, AX into sin phi for first case. For second case, AY into sin theta sin phi, AY into cos theta sin phi, AY into cos phi. Same way, if we are supposed to find out this point in Z direction, then we will consider this row. Okay, how? First of all, we will calculate that AR is equal to AZ into cos theta. Second, A theta is equal to AZ into minus of sin theta, and A phi is equal to AZ into 0, that means 0. So from this table we have plotted this set of equations. See, these equations are not part of this example, but as we are using this table, it is very important for us that we should know from where these equations are derived. Okay, so now we will start the example. Okay, first step that they have asked, first point, tan AX at P of X, Y and Z. So we will write down these three set of equations whatever we have write earlier, AR, A theta and A phi, AR, A theta and A phi. These equations are first AX into sin theta cos phi, AX into cos theta cos phi, and last AX into minus of sin phi. Okay, what is AX here? We have already given in the data, that is 10 AX. So we will put value of AX as 10. Okay, then AR will become 10 sin theta cos phi, AX will become A theta will become 10 cos theta cos phi, and A phi will become 10 into minus of sin phi, that is equal to minus of 10 sin phi. Okay, so we are having values of AR, A theta and A phi, AR, A theta and A phi, but we are having unknowns in it. What are the unknowns? Our theta and phi. So from where we will find this theta and phi? With the help of our system. Okay, what kind of system? That we can find out this value of theta and phi from the conversion from Cartesian to spherical. Okay, now we will use this table. See this table. Okay, in this table we are given that if you want to convert from Cartesian to spherical, that means from x, y, z to r, theta and phi, you have to use this row. So r, how we will calculate the value of r? With the help of square root of x square plus y square plus z square. Okay, we are having value of x, y and z, that is minus 3, 2 and 4. we will put all these values of these into this equation, so we'll get answer as 5.385. Next is to find out the value of phi, that is tan inverse y by x. Y by x, that means tan inverse of y, that is 2, x, that is -3. So from that we will have answer of 146.31 degree. Last is theta. Theta is equal to cos inverse of z by r. Now z is our 4 and r is whatever we have calculated earlier, that is 5.385. If we put this value in this equation, we will get answer of 42.0 degree. Okay, so these unknown values theta and phi, we got that value in this. Okay, we have to put this into this equation, ar, a theta and a phi. So what was the value? Tan sin theta cos phi. Theta is 42, phi is 146.31. Put this value into ar, we'll have value of ar is equal to minus 5.568, a phi minus 5.546. How? A phi is equal to minus of tan sin phi. Minus of tan sin into phi is 146.31 minus 5.546. A theta is equal to tan cos theta cos phi. Tan cos of theta is 42, cos 5 is 146.31. okay, this is how we can calculate the values ar, a theta and a phi. Now put all these values into the main equation. Our main vector quantity was ar into unit direction of r, a theta into unit direction of theta, a phi into unit direction of a phi. Okay, so by putting all these three values in this equation, we will have main equation as a vector is equal to minus 5.568 into unit vector of r plus minus of 5.546, that will become minus of theta 6.183 into unit vector of theta plus a5 that is minus of 546 minus of 5.55 a5. So what we have done here, we have basically find out the vector a to the point or in the direction of ax, and the magnitude of ax was 10. So this is how we can calculate the conversion between any 3 points. Here in this case we are having Cartesian to spherical in specific direction, that was 10ax. okay, now moving toward next case. In next case, from the data they have given that to find out 10ay, earlier it was 10ax. In this we have to find ay at q of r, phi and z. That means our q point is given in r, phi and z, that means in cylindrical system. Okay, so we can't convert any system which is in cylindrical to directly spherical. We have to convert this cylindrical to Cartesian, that is in x, y, z, then we can convert that into spherical. So how we will do that? So first of all, we have written that the data 10ay at q of r, phi and z, which is in cylindrical, so we have to convert them into Cartesian first. But before converting into the Cartesian, we have written the all equations from this table. Okay, ar is equal to ay into sin theta sin phi, a theta is equal to ay into cos theta sin phi, and last one a phi is equal to ay into cos phi. Okay, just put it all the values. In our case we have already mentioned ay, the magnitude of ay is 10, so we'll put the value of ay is equal to 10 sin theta sin phi, 10 cos theta sin phi and 10 of cos phi. Okay, as we have done in first case. Okay, now as we have discussed that we can't convert any system which is in cylindrical directly to the spherical. We have to convert that system into the Cartesian first. So we will convert this r, phi and z into x, y and z. How? By using the table. Okay, our system is given in cylindrical. So with the help of this table we'll find out that if we are having values of r, phi and z, this is how we can convert that into x, y and z. X is equal to r cos phi, y is equal to r sin phi and z is equal to z. So just by putting the values of phi we can simply calculate x, y and z. What is x? R cos phi. R is equal to 5 cos of 30, y is equal to r sin of 30 and z is equal to z. By simply putting the values we can calculate x, y and z. After converting to x, y and z, now we will jump towards by converting these x, y, z into our main purpose, that is to convert into spherical. So by using these equations, Cartesian to spherical, see r, theta and phi, if we are having values of x, y and z, we can simply convert into Cartesian to spherical. So r is equal to x square plus y square plus z square. By putting just value we will get 6.40. Theta is equal to cos inverse z by r. Z is our 4 and r whatever we have calculated 6.40. Phi is equal to tan inverse y by x. Y is 2.5 and x is 4.33. We'll get answer of 30 degree. Okay, so simply we have converted our Q point into r, theta and phi. Okay, cylindrical to spherical we have already converted. Okay, now next step is to put these values into this ar, a, theta and phi as we have done in case 1. So how we will put that? We have having value of theta and phi, theta and phi and phi. So we will put this value into this equation: 10 sin theta sin phi, 10 cos theta sin phi, 10 cos 30. Put all these value of theta and phi into the ar, a, theta and phi. So we'll get value of ar, a, theta and a phi, and we will put all these main magnitude values of ar, a, theta and a phi into the vector equation that was here. A vector is equal to ar into unit direction of r plus a theta into unit direction of theta, a phi into unit direction of phi. So this is how, by putting these values, we can calculate a vector is equal to 3.9 ar plus 3.125 a theta plus 8.66 a phi. Okay, this was for second case. Now moving towards next case, that is last, tan az at r is equal to r, theta and phi. Now as we know r, theta and phi, that means this point r is already given into spherical coordinates, because its spherical coordinates contains r, theta and phi. So we are not supposed to convert this system into any other system, but by using simple values we can convert these all three values into particular one point, that is our tan az. So by using this table, these equations, ar is equal to az into cos theta, a theta is equal to az into minus of sin theta, and a phi is equal to 0, which we have derived from this table, this new table. Okay, cos theta minus sin theta and 0. Okay, for az. Okay, we have derived these equations. Simply put the values of az into this equation. Az is 10 cos of theta we have already 110. By putting 110 we'll have 10 cos of 110, one answer. A theta is equal to az into minus of sin theta, Az, what is Az? 10 already given. This minus sign will go here, that will become minus of 10 sine of 110. We'll get one answer, minus of 9.4, and a5 is 0 is equal to 0, no answer will there. So by putting now this value into the main vector equation, this equation, we will get value of a vector is equal to minus 3.42 unit vector of r minus 9.4 unit vector of theta plus 0. We won't write. Okay, this is how we can calculate conversion between any two systems, okay, in specific one magnitude or in one specified direction or in point. In this example we have ax, ay and az. Okay.